Let's go to example 2. A company currently has 600 employees. The number of employees is expected to grow at a rate of 3% each year. Write an exponential function to model the number of employees in the company Y after X years. Growth at rate of 3% each year. This is an exponential growth function. Formula will be y equals a times 1 plus r to the x power. This r is a growth rate. Growth rate is 3%. 3% equals 0.03. So we get y equals A is the initial value, 600, times 1 plus 0.03 to the x power equals 600 times 1.03 to the x power. Let's go to B. Another company currently has 800 employees. Because of AI, the number of employees is expected to decrease at a rate of 2% each year. Write an exponential function to model the number of employees in this company Y after X years. Decreases at rate of 2% means this is an exponential decay. The formula for exponential decay is y equals a times 1 minus r to the power of x. This r is the decay rate. Given here 2%. 2% equals 0.02. So y equals initial value is 800 times 1 minus 0.02 to the power of x. Simplify 800 times 1 minus 0.02 is 0.98 to the power of x. Let's go to example 3. Researchers studied the population of a town over time and modeled the data using an exponential function. The initial estimated population was 48,000. After the first year, the population of the town was 50,400. If the population of the town continued to grow at this rate each year, which function can be used to model the population of X years after the researchers begin their study? Let's make a table. X, Y. When X equals 0, Y equals 48,000. When X equals 1, Y equals 50,400. Let's go to Desmos. Delete all. Then add a table. 0, 1, 48,000, 50,400. Okay, click here. Type in y1 is approximate to a times b to the power of x1. So we are given a equals 48,000, b is 1.05. So we get y equals 48,000 times 1.05 to the x power. Therefore, this is wrong. Check inside. We got 1.05. Therefore, A is the solution. Let's go to example 4. A customer purchases an electronic device for $650. Each year, the value of the electronic device decreases by 30%. Decreases by means this is an exponential decay. Which statement is true about the graph that represents the relationship between the value of a device in dollars, y, and the number of years, x, since the device was purchased? Exponential decay formula is y equals a times 1 minus r to the power of x. A is 650. This is also called the initial value, times 1 minus 30% is 0.3. Then to the power of x. So we get 650 times 0.7 to the power of x. Click here, delete all. Then type in this exponential decay. The y-intercept of the graph is 650. Zoom out. Yes, the y-intercept of the graph is 650. So answer is A. But let's check BCD. See where it's wrong. Y-intercept of graph is 455. No, this is wrong. Remember, this A is y-intercept, and also called the initial value. Let's go to C. The graph has a vertical asymptote line. Let's check back the graph. Let's zoom in. Look at this graph. We have a horizontal asymptote line, x-axis, which is y equals 0. So horizontal asymptote line is y equals 0.